All right, let's get right into it. There is something hurtling through our solar system right now, an interstellar visitor that is just breaking all the rules. It's a comet called 3I/Atlas, and honestly, it's making scientists question pretty much everything they thought they knew about these cosmic travelers. Because that's really the heart of it, isn't it? We are looking at something out there in space that, based on everything we know, just shouldn't be possible. And the answer, whatever it is, could literally change our understanding of the entire universe. So this whole story kicks off in November of 2025. And it doesn't start in some billion-dollar observatory. No, it starts with an amateur astronomer pointing their own telescope at the night sky. And what they found has ignited a global scientific race to figure out what's going on. So get this, from the incredible dark skies of Hawaii, an observer who goes by Copa stars uses a smart telescope to grab a picture of 3I/Atlas. And they saw something that just shouldn't be there. It wasn't just the normal tail we expect, the one pointing away from the sun. No, there was a second tail, an impossibly sharp, razor-thin line pointing the wrong way, directly into the solar wind, straight towards the sun. And I want to be super clear here. We are not talking about some faint, little blurry smudge in the sky. This anti-tail was bright, it was perfectly straight, and it was unbelievably stable over time. You have to understand, in the total chaos of space, with the sun blasting radiation everywhere, seeing that kind of perfect, clean order, well, that's enough to make any astrophysicist stop in their tracks. So naturally, the first reaction from everyone was, okay, this has to be some kind of trick of the light, right? An optical illusion. It's something we've seen before. But as we're about to see, when you look at the actual data from 3I/Atlas, that simple explanation just doesn't hold up. Okay, so normally what astronomers call an anti-tail is really just a matter of perspective. Think of it like this. Picture a car driving down a really dusty road. It kicks up this huge, wide cloud of dust behind it, right? But if you're standing way, way down the road, looking right at the car as it drives away from you, that big, wide cloud just looks like a single thin line. That's a normal anti-tail. It's just us, on Earth, looking at a comet's big, messy dust trail from the perfect angle that makes it look like a spike. But here's the problem. 3I/Atlas just refuses to fit that picture. A typical anti-tail, that illusion, it's supposed to be broad and fuzzy, made of a jumble of different sized dust bits. This one, it's razor thin. They're usually faint and they vanish as our angle changes. This one, it's super bright and totally stable. I mean, to get a line that sharp, the particles making it up would have to be almost perfectly uniform in size and weight, which is something that just basically never happens in nature. Which, of course, brings us right back to the big mystery. If this thing isn't an illusion, then what in the world is it? What kind of physics could possibly create and then maintain such a perfectly straight line against the constant, powerful blast of the solar wind? Right now, the debate has pretty much split the scientific community into two main camps, leaving us with two absolutely extraordinary possibilities. So let's treat them like the two main suspects in this cosmic whodunit. Okay, so on one side, you've got theory A. This is something completely natural, but it's a kind of object we have never ever seen before, a literal chunk of a dead planet's metallic core. Then, on the other side, you have theory B, which is pushed by respected researchers like Avi Loeb. The object's structure is just too perfect, too orderly. It might actually be artificial. Let's dig into suspect number one, the natural explanation. The idea here is that 3I/Atlas isn't your classic dirty snowball comet at all. Instead, it's a super dense piece of iron and nickel, a fragment from the core of a planet that got smashed to bits a long, long time ago. Grains of dust made of heavy metal wouldn't get pushed around so easily by the solar wind, which could, maybe, let them form that perfect sharp line. If this is true, it means we are literally looking at a geological sample from an alien solar system. How cool is that? Now for suspect number two. This side argues that nature just isn't this neat and tidy. The level of uniformity, the stability, it's just too perfect. Proponents of this idea, like Avi Loeb, are suggesting we're not even looking at a trail of dust. They think it could be a stable, physical part of the object itself, or maybe even some kind of controlled emission, holding its shape because it was designed to. And this quote right here, it just perfectly nails the core argument for that second theory. Now look, it's definitely the more speculative view, but the reason it's even on the table is because the standard models are having a really, really hard time explaining what we're seeing. That difficulty is what's keeping this wild but profound possibility alive.
And this isn't just some abstract debate for the future. I mean, the entire scientific community is in an absolute race against the clock to solve this thing while 3i Atlas is still close enough to study. This is science happening as we speak, pixel by pixel.
And they've got a plan. There are two huge, critical tests coming up this December that are specifically designed to give us a definitive answer and, hopefully, finally unmask this mysterious cosmic visitor. First up is the geometry test. As Earth continues in its orbit, our viewing angle of the comet is going to change. Now, if that anti-tail is just an illusion, it should start to widen and fade away as our perspective shifts. But if it stays razor thin, the illusion theory is dead. Second, the James Webb Space Telescope is going to perform a spectroscopy test, basically breaking down the light coming from that tail to read its chemical fingerprint.
And here is what the Webb telescope is looking for. It's pretty straightforward. If the spectrum shows common stuff like silicates and iron, well, that points very strongly to a natural, rocky origin. But if it finds refined alloys or elements that have no business being together in nature, that would be incredibly powerful evidence for an artificial origin. And all of this is happening incredibly fast. In early December, we get the data from the Webb telescope. By the middle of December, the geometry test gives us its verdict, and it is all building up to the main event on December 19th.
On this day, 3i/Atlas makes its closest approach to the sun. It is going to get blasted by the most intense heat and radiation of its entire trip through our solar system. So will that impossible tail hold together? Or is it going to break apart under the strain? This is the ultimate stress test. You know what's so amazing about all this? We all have a front row seat. This whole incredible mystery was kicked off by an amateur astronomer, and now a worldwide network of observers is working right alongside NASA and other major space agencies. It's just a perfect example of this new era of science where anyone, anywhere, can contribute to a discovery that could rewrite our textbooks. So that's where we stand, with this one massive question hanging over us. No matter what the answer turns out to be, it is going to be profound. Are we looking at the ghost of a shattered world from another star? Or are we seeing the first credible piece of evidence of technology beyond our own? The next few weeks are going to tell us.